In this video, we're just going to look at a couple of examples of synthetic division start to finish. So let's dive right in. The only directions here are to divide using synthetic division. So let's get with the proper setup. So we'll start with the setup. Here, this is supposed to be of the form x plus k, which in this particular case is x plus a negative 2. So our k value is negative 2. So we set up our crook. We put in our coefficients. Our coefficients are 3, negative 5, 2, and negative 1. 3, and negative 5, 2, negative 1. We have our horizontal bar. And then, of course, we have to use the opposite of our k value. So if k is negative 2, then we're going to use a positive 2 here. This is our negative k, and we begin. We begin by dropping our first coefficient below the bar. We then multiply. 2 times 3 is 6, and we place that above the bar in the next position. We then add, and we get a 1. Then we repeat. 2 times 1 is 2. We add those together and we get a 4. And then 2 times 4 is 8. And we add that column and we get a 7. And we separate that last value from the other coefficients and constant because that is our remainder. So this is our remainder. This is our constant, x and x squared. And our result is 3x cubed minus 5x squared plus 2x minus 1 over x minus 2 is 3x squared plus x plus 4 plus a remainder of 7 over x minus 2. And that's our result. Now, one thing I haven't done in any of the videos about synthetic division is show you that you will get exactly the same thing if you do long division. It's just, well, longer. So if it's been a while since you've done any long division, let me just illustrate that for you really quick. We're talking about doing x minus 2 divided into 3x cubed minus 5x squared plus 2x minus 1. And this is a bit long-winded, and hopefully you can appreciate how fast that synthetic division was. The first thing that we need to do is we need to focus in on our leading terms. And our leading terms are x and 3x cubed. And so I need to ask myself, what do I got to multiply x by to give me that first term? And the answer is a 3x squared. And I would place that in the squared column. And then what I would do, I would multiply. And I would multiply by every value up here. So let's see, we get a 3x squared times x. That's the 3x cubed by design. And then 3x squared times negative 2 is a negative 6x squared. And then we would subtract using the old school rules of long division. And 3x cubed minus 3x cubed is 0. And negative 5x squared minus a negative 6x squared gives us a positive 1x squared. And then we would bring down the other terms, 2x and negative 1. And then we would repeat this process. Now I got to take a look and see what I got to multiply x by to give me x squared. And the answer is, well, another x. And then I would distribute there as well. And I would get an x squared minus 2x, parentheses, subtract. That would give me another 0 there. And then 2x minus negative 2x, careful, is a positive 4x. And then I would bring down that negative 1. And I would repeat this process one more time. And x times what gives me 4x? Well, positive 4. And 4 times x is 4x. And 4 times negative 2 is negative 8. Parentheses, subtract. And that will give me 0. And negative 1 minus negative 8 is a positive 7. And that would be my remainder. And so this would be plus a remainder of 7 over x minus 2. And you can see that we get exactly the same answer as above. So they are the same process. They look different. They might feel a little bit different, but one is definitely faster. And probably has a lot less room for error because we're doing addition here as opposed to subtracting, and sometimes we have to subtract a negative. So be careful. Here we go with our next example. Now don't let the A's fool you. This is still the variable. But what's important here is the setup. So watch how this is done. Again, what we want to do is we want to identify our k value. This is our quote-unquote x plus k, or in this case, a plus k, where our k value is equal to 2. So when we set this up, we're going to be using the opposite of the k value, negative k, which is a negative 2. And our coefficients are the coefficients. Well, that one doesn't seem to have a coefficient, but it actually does. It's got a coefficient of 1, as does this one. And so when we set this up, we have one a to the fourth, we have 1a cubed, and this is really important here. We actually have 0a squareds, 0 a's, and then a constant of negative 1. So don't forget your placeholders here. This is no a squareds plus no a's. Placeholders. And they're key to getting this problem correct. Okay, the rest of this is pretty straightforward. Get our horizontal bar. We'll drop our first coefficient of 1, and we'll begin this process. Negative 2 times 1, that's going to give us a negative 2. And then we'll add, and that'll give us negative 1. We'll then do negative 2 times negative 1, which is positive 2. We'll add those together, and that'll give us a 2. We'll then do negative 2 times 2, which is a negative 4. We'll add those together, and we'll get negative 4. And then we'll do negative 2 times negative 4, and that will give us a positive 8. We'll add those two together, and we'll get a remainder of 7. So there's our result for that synthetic division. And as we interpret our answers, this is our remainder. This is starting from right to left, the constant. This is x squared, and this is x cubed. And so, well, actually they're not x's, right? That was a mistake. So what I meant was this constant a squared, a cubed. So what we have here is a to the fourth plus a cubed minus 1 divided by a plus 2 is a cubed minus a squared plus 2a minus 4 plus a remainder of 7 over a plus 2. And that's our final answer for this problem. Okay. Whoops, let me leave that up there. Last one. Let's get our setup straight here. Our k value is negative 3, so we'll use the opposite of our k value. That is a 3. Our coefficients are 1y to the fourth, 0y cubes, 0y squareds, 0 y's, and a constant of negative 81. So again, this is 1y to the fourth plus 0y cubes plus 0y squareds plus 0y minus 81. So again, placeholders, y'all. Get it. And the adventure begins. Here we go. We're going to drop the 1. 3 times 1 is 3. We'll add 3 and 0. That'll give us 3. 3 times 3 is 9. We'll add 9 and 0. That'll give us 9. 3 times 9 is 27. Plus 0 is 27. And 3 times 27 is 81. And negative 81 and 81 is 0. And that's our remainder. This is our constant, y squared, y cubed term. And so y to the 4th minus 81 over y minus 3 is y cubed plus 3y squared plus 9y plus 27 with no remainder. That is to say, it actually went in evenly, divided in an even number of times. And that's how you perform synthetic division. So a couple of things that are important here to say. This process is deceptively straightforward. Once you learn it, it's actually pretty easy to do, but you got to learn the setup first. So let's go over that again. So A. When can synthetic division be used? Well, we must divide by x plus k. How do we know what power of the variable the quotient begins with? So what are we talking about here? How do I know that this is a cube? Well, when I did this, I just started counting from right to left. I said constant, first power, second power, third power. But another way to remember this is the top is a fourth power, the bottom is a first power, and so when you take a fourth power and you divide by a first power, you should end up with a third power. So B, the degree of the quotient, that's the answer, is top degree minus bottom degree. What number goes in the top left bracket? So this is the opposite of k. So for x plus k, we use negative k for our divisor. And then finally, how do we handle missing powers of the variable in our dividend, the thing that we're dividing into? Don't forget to use placeholder zeros for missing terms. And if you remember those 4 things in the setup, there's no reason why you shouldn't be able to do these problems quickly and efficiently. Okay.